Page 7. This is going to be all about matter. These particle diagrams. All matter can be broken up into either pure substances or mixtures. If they're pure, they either have to be elements or compounds. So some of these questions, which of these are mixtures? A is all the same. B is a mixture. B is a mixture. Two different kinds of things in there. Which of these are pure? Well, anything that's not a mixture must be pure. A is pure. It's a pure. And so is C. Those are both pure. A happens to be pure compound because it's lots of different shapes tied together, though they're all the same ratio. C is a pure element. It didn't ask us that. Maybe it does. Which does not contain a compound? Well, A does. B contains a compound. D contains a compound. Letter C only contained an element. Which these ones are mixtures, so I'm looking for two or more different kinds of things. It's tough. Looking at B, you can't quite tell which things are really touching, but none of these are mixtures. They are all a pure substance. Every single one of these is a pure substance, which contains a gas. Look for the ones where the particles aren't really touching. That would be A. That would be C. Which could contain a liquid. I wish it was down at the bottom of the thing, but it's not. But B is kind of close, kind of touching, but not very neatly arranged. And finally, D is the solid because they are nice and neatly arranged. Percent composition. I will say this often as the part over the whole. Which parts over the whole do the number times 100%. You have to figure out which substances we're using. For this one, phosphoric acid is H3PO4. So we got to know which percent is H, which percent is P, and which percent is O. My answer is going to be percent hydrogen, percent phosphorus. Whatever's left will be percent oxygen. A sample is decomposed into 9 grams of hydrogen, 93 grams, and 192. First thing I need to know is the whole. How much was that when it was all together? 92. No. 9 plus 93 plus 192 means that I had a grand total of 294. The whole will be 294 grams. I will use that every single time. Every single time the whole was 294 grams. So which part was hydrogen? 9 grams was hydrogen. Which part was phosphorus? 93 grams was phosphorus. And which part was oxygen? 192 grams. I like to write the 100. You don't have to, but you just got to remember to move it over 2 places. 9 divided by 294. I'm seeing 0.03, but that's move the decimal place over. 3% hydrogen. 93 divided by also 294, because that's the whole. When I move the decimal over, it's going to be about 32%. I'm taking this times 100 equals 31.6, and I'm just rounding. Last one, 192 divided by 294 equals that, times 100 equals 65-ish percent. So I'll write 65%. I like to do a little reality check. 65 plus 32 is 98, plus 3 is 101. With rounding, it looks like I did things correctly. A different way of looking at it, if you have a 750 gram sample of phosphoric acid, how many grams of each of the 3 elements would you have? Okay, we know that we have 3 elements. We got to figure it out for H. We got to figure it out for P. We got to figure out for O. I can kind of just extend this down. It's all based on the same numbers. So each one of them I have 750 grams. That's kind of like the whole this time. I'm not putting the parts over the whole. I'm going in the other way around this time. How much is hydrogen? 3% or 3 100ths. How much is phosphorus? 32% or 32 100ths. How much is Oxygen, 65. Some people just write that as 0.65. Understand that percent can be written that way instead. It's all the same. It doesn't matter. 750 times 3 divided by 100 equals 22.5 grams of hydrogen. 750 times 0.32, which is the same as 32 divided by 100, equals 240 grams of P. And 750 times 0.65 equals 487. 487.5 grams of oxygen. If I wanted to check my work, I could add up this number, this number, this number, and make sure that I get 750.